Okay, welcome to Purple Shirted Nerd, and we're going to go through some trig identities. This was part of an assignment. These are commonly asked questions from students I've had, so I'd assume that these would be ones that may be a bit more challenging than the norm. So I think this will be more than a one-part series. I'm just going to go through three identities with you here, and maybe you can pick up something from this that can apply to some other identities as well. So let's get started. Oh, well, this one, I can see why this is asked. It's just so odd looking compared to many that we look at here. One thing I really want to stress is we have too many students that just focus on what can I do, for instance, if we're going to work on the left side of this equation, what can I do to the left? When what we need to be doing is at least spending 50% of our time thinking about the right side. In other words, what can I do to make the left side look like the right side? I don't want to just make moves for the sake of making moves. One thing I noticed right at the beginning, I may be tempted on the right side over here to treat this as just cosine cubed x. And, just like x to the 1/2 is square root of x, square root sine of x could be written as sine 1/2 x. So now, on the right side, if I consider that my target, I want to make the left side look like the right side. The right side has factors of cosine and a half factor of sine. So I would love to get factors of cosine and sine out of this binomial. But clearly, they both have a cosine I could pull out. I could factor out a cosine. They also can each afford a half factor of sine. So I'm going to start this by factoring out a half sine to the 1/2 of x, and a cosine x, which leaves me from this first term with, if I divide both those out, I'm just left with 1 minus. And people get stuck on this next one. Oh, I take sine half out from x. What's left there? Well, if I had x to the 5th and I factored out an x squared, I'd be left with x cubed. We just subtract those. So 5 halves minus 1/2 is 4 halves. 4 halves is 2. And I've factored out the cosine. I have this. And you may see this just laying in your lap right now, but if you don't, you're going to. This is so good it's practically cheating. Let's see what we've got. I matched that factor. I've matched one of those. I need 2 more. Is 1 minus sine squared equal to cosine squared? Well, here's thought bubble. You wouldn't write this down necessarily, but I know that sine squared of x plus cosine squared of x equals 1. So 1 minus sine squared x is positive cosine squared x. Now, should we go straight to our solution here? No, you owe it to the reader to see where the final answer comes from. So this is sine 1/2 x cosine x times cosine squared x. Now, anybody with reasonable algebra skills at that point could say, oh, I guess cosine squared of x must be 1 minus sine squared of x, because this just came here. So the reader can follow this. Equals. At that point, sine 1/2 x cosine times cosine squared is cosine cubed x, does in fact equal cosine cubed x times sine 1/2 x. So again, what the big point here that I want to make, and you're going to hear me make it over and over, one of the biggest weaknesses people have is they just start doing stuff. Equivalent to playing a chess game and just starting moving pieces without any thought of what your goal is, without any thought of defending or attacking your king. We just, I can move my knight from this position up here, and over 1 and put it here. Let's give some thought to our target. What are we shooting at? Okay. Oh boy, this one is a mess too. I can see why people would ask questions on this. In fact, I think I might rewrite this and give myself just a little bit more room here off to the left. So I'm going to rewrite this. Maybe at the same time I'll do this with it. 1 plus sine of theta on square root 1 minus sine of theta equals 1 plus sine of theta on the mysterious absolute value cosine of theta. Okay, well, there may be a temptation to square both sides and get rid of this square root. Can't do it in an identity problem. We don't know these are equal. And in fact, squaring both sides, even algebraically, presents some challenges because -3 does not equal 3. But when I introduce squaring both sides, I turn a false statement into a true statement. So if I'm going to work on the left side, because that absolute value intimidates me a little bit, I'm not going to work on the left side and just blindly omit the right side. I'm going to look at the right side and say, what looks good? What looks close? Well, my numerator's pretty close right here. If I could square the top and square the bottom, would that be okay? Well, does 2/3 equal 4/9? Of course not. We can't just square the top, square the bottom. That changes the value of a fraction. But what I could do is multiply the top by 1 plus sine of theta if I multiplied the bottom by 1 plus sine of theta. Why can I do that? That is a fancy form of 1. I'm just multiplying by 1. What's the good news there? Well, the good news is the numerator, I just matched my factor. 1 plus sine of theta is the only factor in the numerator that I'm going for. The denominator, okay, that's square root. If I FOIL this, I get 1 minus sine squared of theta. And that's supposed to equal 1 plus sine of theta, all on absolute value cosine of theta. Let's talk about the absolute value, because I can see that this is 1 plus sine of theta on square root cosine squared of theta. 1 minus sine squared is cosine squared of theta. But what about that absolute value? And that's a tricky one for us at times, but I would say, how about this? If I said square root of 7 squared, we all know that's 7, right? What is square root of -7 squared if I write it like this? Isn't that also 7? So to say that square root of x squared is x is really not true, because in this case, square root of -7 squared is not -7. So square root of x squared might not be x if x is a negative number. If x is a negative number, square root of x squared is the opposite of x, or the absolute value of x. Square root of x squared is the absolute value of x, and that's where we come up with, and I have run myself out of room here, so this is to be continued right here. That's where we come up with 1 plus sine of theta on absolute value cosine of theta. Okay, so a bit tricky there. There's some real temptations that get people in trouble, and one of those is definitely square both sides. Not allowed to do that. One of those is just square top, square bottom. Can't do that. We change the value. And of course, the third is this sneaky little absolute value. Hopefully that helps explain that one to you. Okay. Oh, this is so awesome. It's cheating. So good. Tangent cubed of, I don't know, let's call that fish. Tangent cubed of fish minus 1 on tangent fish minus 1 is supposed to equal tangent squared of a plus tangent of a plus 1. All right, I think I'm going to work with this on the left. Now, you are fully equipped if you know how the difference of perfect cubes factors. If not, and we're going to talk about this match the factor idea just a little bit. This is going to be, this factors into a minus b times a squared plus ab minus, or plus, excuse me, b squared. That's how that guy factors. Now, let's think about this for a minute. Let's just say we were just kind of experimenting, and we said, well, the denominator tangent of fish minus 1, if I look at my target, I must cancel that denominator somewhere, so I must be able to make a factor of tangent minus 1 in the numerator, and once that's canceled, what's left? tangent squared fish plus tangent fish plus 1 is what I want to have left. That equals, oh, okay, tangent squared fish plus tangent fish plus 1. Now that might be a little bit mysterious to you, but what I was doing right there was just kind of reasoning, if this is truly an identity, this must cancel from a factor of this, and what must be left is that. So does this superfoil out to be that? Well, let's take a look. If we weren't approaching it that way and we were fully equipped, as I said, to handle this, then tangent cubed a, or tangent cubed fish minus 1 becomes tangent fish minus 1 times tangent fish squared, got it, plus AB, that's tangent fish times, that looks terrible, that's tangent fish times 1 plus 1 squared. All on tangent fish minus 1. Now, if you joined late here, you weren't paying attention, you realize I just wrote the same thing twice, but that was from two different perspectives. This was I knew how to factor the difference of perfect cubes. This was, man, I hope this works. I needed to cancel this, and I needed to be left with that in order for this to work. That's pretty slick. Okay, so you can look forward. I will title the next video, if I have one on this, I will just title that Part 2. This would be some of the tougher identity problems that we had from our Section 5.2. If you just joined us, welcome. Hope you got something out of this as well. Good luck.